I'm going to do an example of a Bode plot where there is a pole at 0. Our method is to take the DC gain of the whole system and then plot the individual poles as if they all have a DC gain of 1 and then combine all of it together. The other way you could do it is to break it and do each of the poles individually. So I could rewrite it like this, where I've just separated out the 3 poles, do the Bode plot for this, do the Bode plot for this, do the Bode plot for this, add them all together. So when you have a system with a 1 over s or an s in the numerator, you can factor that out, do the Bode plot for the rest of the system, and then add the two effects together. You can actually do that for any combination of poles or zeros that you want. You can factor pieces out, do them separately, add them back together in the end. So let's do it for this. I'm going to find the DC gain, or that's equivalent to 20 log of 0.01 minus 40 dB. So I'm going to begin with the DC gain of minus 40 dB. That takes care of the 0 and the pole. Now let's plot in the individual pieces. Well, we have the 1 over s. That's 20 dB per decade. The orange line corresponds to a pole at 0. Notice that the pole at 0 keeps going up. It never levels off. And this is a log scale, so 0 on a log scale is infinitely far back. This is 0.01, 0.001, 0.0001, and so on. This keeps getting larger and larger. That's the problem when you have the DC gain, right? You put a 0 in here, it blows up, it goes to infinity, which is really what happens. At a DC, you integrate it, ends up being an infinite value. Next, I'm going to put in the 0 at 0.1. So the 0 at 0.1, now I've already accounted for the DC gain, so I can go 0, and at 0.1 it goes up 20 dB per decade, and so it looks like this. Next, I put in the pole at 10. Again, I've accounted for the DC gain of that here, and then down 20 dB per decade. And the final step is to add all of these lines together to get the final piece. And the green curve is the total gain plot for this function. Next, let's do the phase. First, let's plot in the yellow for the integrator. That's a constant 90 degrees, constant minus 90 degrees. Next, let's plot in the 0. The 0 crosses here, has a total phase shift of 90 degrees spread over 2 decades. The phase shift for the pole, again, total of 90 degrees spread out over 2 decades, centered at the pole location, which is 10. And then we need to add these together.